Yeah.
But it still will remain configuration based at least for cluster computers. Because this can be used by some other data.
And actually, these APIs gives you the possibility to create dynamic shards, to create APIs for dynamic shard creation. So it doesn't preclude you from having just config based. It just opens a new possibility for dynamically spinning shards, for having shards which are only local to the controller, remote shards, and then maybe probably to spin up new shards. Yeah, and that.
But the data tree shard that you register, is expected to implement some other interface. It doesn't say all it has on it is get parent or something.
Yeah.
So, I mean, there's got to be more glue that says if you want to dynamically spin up a new cluster data store shard.
So, yeah, this API is capability based. So you register a data tree shard, and usually your shard will have you will implement the data store SPI, that you have a read write transaction.
Implement the data store API. What they really want to do is say here, cluster data store, here is another.
And these are the user-facing API. Yeah, and they are user-facing API. These APIs are to make that possible.
No, this SPI is for anybody implementing a data store. So
what I'm saying is it doesn't seem like this API is suitable for dynamically spinning up a new shard replica or a new shard.
No, that's not suitable for that yet.
Right.
That's what we started. We started with really core, and then based on your ideas, we could introduce that SPI, and probably you will design it better than me. I can design this really low level tailored to how MDSAL works, and for the user facing, I believe you two will be better for clustered user facing SPIs.
Yeah, okay, that's cool. It's not gonna
So the other part which Moiz asked is we had also, along with the sharding SPI, there were proposed a set of new data tree APIs. This is a set of new APIs. Why it renders always like that? These APIs introduce basically new things which are subtree bound transactions. So you specify to which subtree you are writing beforehand, before you start actually doing any work. The transaction chaining is a natural part of the API. It's easier to use. It's called data tree producer. And actually difference between, and actually it is a signal to the MDSAL or to the underlying implementation. I will be doing a lot of writes to that particular data, to that particular subtree. And also given that this actually proposes also the better threading model for the applications which are using the data change listeners. So before we said do not do heavy work inside the MDSAL thread. If you will be using opting into data tree APIs, you will be safe to use data tree change listeners and to write back to the data store during the data change listener callbacks. And also it allows us later to introduce maybe on per shard basis or configuration basis enforcement of the single writer. So there is an exception which could be, there are exceptions and contract which could notify the application that this subtree could be maintained by someone else. So it allows actually application to specify that I don't want someone else to stomp over and rewrite my operational data, for example. As I mentioned that before we discussed instance identifier-based microsharding. It's basically mapping of the instance identifier to shards, and allows us to introduce later on dynamic and programmatic shard creation.
Okay with sharding API.
Yeah.
Let's delve into that data tree API, because that actually affects end users, right?
Yeah. As it is still, it's opt-in. If we introduce it in Beryllium, it's opt-in. Yeah. but I will push to migrate as much.
Is it such that we have to use one API or the other, or can we use both?
As an application, I would prefer that the application will use one type of the API or the other. Then there are the applications actually. So one style of the API or the other. Actually, there are applications which are using, for example, binding and DOM at the same time, and it makes sense in their use cases also. But they are not using that different concepts or different levels of the APIs. Current APIs are Helium level. They are Helium style APIs. They were introduced in the Helium. In the Lithium, we did not introduce any new APIs. And we are proposing a new APIs for the Beryllium based on what we learned by some other large-scale applications we created in the Open Daylight, and by the request from the projects like GBP and the others. What actually was painful for them using the Helium-style APIs.
Are we going to replicate anything from the Helium style APIs? Because is read going to be a different thing? Is read like transaction?
I need first to convince you and community, and then we can discuss deprecation. I cannot enforce that.
Okay, so I mean, let's say we assume nothing will be deprecated from that API.
But we will be discouraged.
Discouraged, but not which means they will use it for one more cycle. Right? I mean, if it's not going to be deprecated.
You need a current API
So we need to figure out that, but I am not pushing for deprecation. I'm So these new APIs doesn't have a read. RESTconf could be implemented using these new APIs. Really simple thing. If you were you working with the AKA?
Yeah, but RESTconf doesn't. You said
No.
talking about UI.
Yeah. So the reads are always implementable using these APIs.
Okay.
Because really, what happens? The read is because given that data change listeners or data tree listeners supports initial change event. That means when you register the data tree listener, you get an initial event. So read is just basically registering data tree listener, getting the event, and closing it.
So RESTconf will be listening to those events, but that's not the case, right? I mean, say I'm a user who logs.
So if you are external user, we promised you to provide a RESTconf contract. RESTconf contract needs to be implemented such way that if you do get, you will get all the data. That doesn't deal, the RESTconf doesn't even affect what MDSAL API is asked. That's different contract. Okay. RESTconf has a different terminology than MDSAL. They are a bit aligned, but they are still a bit different.
But as you mentioned, that read will be
Java API read will be discouraged, not RESTconf read. That's the different API. We are talking about MDSAL here, not RESTconf.
Agreed, but I'm saying with RESTconf, will the read be expensive once you introduce this API or once you introduce this change?
So it will be same expensive as it is currently. So initial data change event is always a read currently internally. So it will be the cost of that. It's similar, maybe a bit large. Will be a bit larger. It depends how we will execute that.
So imagine, like, someone asked from the RESTconf that give me all the nodes in topology. I want to visualize that. So, say imagine you have 50 nodes in a network, 50 switches. So, what would you imagine, like, with the changes that you're proposing?
So if if that is in one chart, we have a read from the data change listeners could read also from the followers. We will not go to the master. If all the nodes in the are present in the one chart, it's similar overhead as doing a read currently. If these are into multiple charts, it will be costlier. But that's already as of now, the read from multiple shards is costly. The cost for that will not change.
But right now we put most of the stuff only in one shard, if you consider about the quality.
So sharding affects performance. Going to the micro sharding and you have the data spread across 10 or 12 nodes in the future, and someone wants to see all the nodes, and you actually did the sharding based that you have nodes in different shards, and you have 12 of them. Yeah, you need to aggregate data from 12 of the shards to provide the RESTconf query. Yeah. Is the RESTconf our primary API or not? And that's the question. If we ask, and that's actually determines how we design the solution. If we go way that we are designing the Java APIs, and most of the applications in the controller will probably be written for the performance, the cost for the RESTconf will be standard. Then we can go with having a RESTconf a bit slower for the reads of the whole inventory, but providing better and faster APIs to Java developers who wants to write these high-performance applications. There is always a trade-off.
I don't see how you can discourage reading from a data source. That's the most basic operation.
So, and that's why, actually, the idea behind this data tree was that the applications like GBP, if you did, and that's there is a difference with what type of the application you are writing. What we saw, and current APIs which we have, works for the offset 1 applications, which are mostly protocol plugins. But once you go to the offset 2, when you are starting to integrating multiple subtrees, multiple types of the data together, having a read, they don't like to actually have a reads. Some of the applications, and that's feedback what we heard from the GBP is group-based policy is that in order to render the policy and, for example, to provision something to the OpenFlow switch, they need to get 5 different subtrees. During the reads, that's 5 futures which they need to propagate correctly, wait for them, and they have still that possibility of the state synchronization between them because these are separate reads, and so on. And what they really asked us is to have a data change listener API, or here is called data tree listener API, where you could listen for multiple subtrees, and you get, once the events come in, you get injected all the multiple subtrees in you.
So basically they would cache it. They would cache the data.
They were doing that caching in their code anyway. And
So it makes sense for them. But another way that, you know, you can do both reads too. Right now the read just takes one instance identifier.
yeah,
Why can't you give it a list of instance identifiers?
no, but, and there comes a bit of a twist here now. You are doing a list. You are maintaining that probably for performance reason in your local cache. Your application has local data we are not aware of. And then discussing application clustering is a bit harder because we don't know about what you did with these reads and how you, and do you need this data migrated if we go into the application level clustering master slave, do you need this data migrated or not? And if you specify that I need these 5 subtrees, we as the clustering MD cell had that information, we are maintaining the data for you. You have less work to do, less data to maintain, and actually we have a better visibility what you need from us. So
So I mean, if they wanted to just cache the data, they can do that right now. I mean, you can have data change listers right now. Are we saying that we will provide something else? We provide the caching also? Is that what it is?
So the caching is one of the options there. The contract is that is when you register for the multiple subtrees, you get 2 objects. One is a collection of data tree changes, what actually happened. And the second one is map of the subtrees you registered to. So basically, all the data you need with their current state. We inject into your application the state you need.
Okay.
So
That's initial.
no, that's all on each event. So basically, your application doesn't need to go and do the reads. Your application is always injecting the current state it needs. Based on that application beforehand registered with all the subtree, with all the instance identifier it needs for itself to work.
So okay.
And that is a snapshot of that moment in time from.
Yeah. Yeah, so the first part is change from the previous state you observed. And you get also the snapshot of all the state you need, of the current snapshot. So we push current state into you. Does it make sense or?
So let's say I'm listening to two different, I register for two different parts of, two different
Yeah.
identifiers. So, initially I get a blob of both. Then, so in one of the paths changes, something changes there. So what am I going to see here? So data tree candidate, I would expect to see a data tree candidate for that because he changed.
Yeah.
The other one didn't change though.
So we will get that back, the original state which is there. The whole thing. You will get the whole thing.
Data tree candidate with the whole thing.
No, you will get the data tree candidate with the subtree which changed.
Okay, so that's the first one.
And in the map, you will get the current state of the subtree which changed and the unchanged state of the previous subtree. So you don't need to do the read. You get injected all these two data into you.
So in other words, data store is really doing the read for you to get the other.
Or we are caching that, or we are getting that from the local follower.
That would be the sharded data broker would be doing that.
Yeah, if the data store doesn't support these APIs, we will do the read.
So you said it sends a snapshot. The snapshot at the time at which that event was generated.
The current snapshot when your thread is able to have event delivered.
Yeah. Event.
So the other part of that, what I mentioned, is better threading model. It means that we deliver a snapshot if some change occurred, and if more changes occurred, you will get all the changes. This API assumes a single threading, so we will not invoke you for multiple threads. And if you are doing processing something, we will compress the changes for you. So you will get the snapshot at the moment we invoke you, not at the moment the change occurred. You will get the current snapshot at the time we are invoking you. Does it make sense? So if your application is doing a lot of computation and there were a lot of small changes, add node, delete node, add node, delete node, add node, delete node, you will see the final state. You will not see these small pieces of it.
What about the changes? Will that be add node, delete node, add node? I mean, those changes, or we just, what will be there in the changes?
So the change will get comprised into one, which that collection is because you could register wildcard, the instance identifier, and at the same time could change the 5 nodes could change.
Do you track what's in?
5 nodes change and their state is compressed into these candidates.
Yeah.
This is like different sub.
Yeah, so that collection actually here is for different subtrees which may change in the same which changed different subtrees. In one transaction you could touch 10 subtrees actually currently. So that collection depends on how many data you are listening changed. If 5 subtrees you are subscribed to change, that collection will be 5. If you subscribe to the one subtree only, without the wildcard instance identifier, that collection will always contain one item.
Are the data tree APIs being enhanced for that? To get a collection of data tree candidates when you actually.
These APIs are working, and application. The part of this API is inspired by the Lithium data tree change APIs. I hate this. So current applications, some of the applications already started using a binding version of these APIs. We have a transition APIs in the Lithium, which are DOM data tree change listener APIs. when you don't have that part, only one part is missing that you don't get that map of current state.
No, actually, I think my question was more related to the data tree itself. Like right now, when you do a prepare with a modification, you get one data tree candidate.
Yeah.
So when you're doing one transaction, aren't you just going to get one candidate? How would you get
Go look into the MDSAL code. There is a code which takes that data tree candidate. Based on the listener registration, it splits off into smaller events.
So then you have to
So that code is already in place, which will translate from the data store type of the candidate into the user visible candidate. It will just split the subtrees of the data tree candidate into separate ones.
So it takes the data tree candidate that you got from applying a modification to a
To-
transaction.
Yeah,
What the data tree candidates would be for the listeners.
for specified listeners. So when you asked about that, listeners, and that's why I sent the code is already there for that part, because we are using it in the Lithium already.
This interface, right?
Not this interface. The the interface which provides a collection of data tree changes.
Yeah, but it's not
Without the,
something slightly different.
it's because it doesn't provide you the data.
But this is a different interface than that. We're not changing that existing.
No, we are not changing that existing one because that's used in the applications.
We'll have free.
Yeah. And actually, each one could be re-implemented on top of each one. Data change in. No. Data tree change is the low level. On top of data tree change listener API, you could implement data tree API, which is the Lithium change event APIs. On top of them, that you could implement data change API, because currently what also is in the code base is that you get a data tree candidate and you change it into these hash maps, which data change API provides you. So these APIs are structured on each other, and actually internally, and this is a bit exposing more the internals of the MDSAL for the users, for the power, because internally, since Helium, the data tree candidate APIs that you are receiving a data tree candidate was in the data store. It wasn't part of the public API, but there was a code which converted it to the public API. There are some applications which asked for some features which we could give by just exposing our internal APIs and making them public API construct. So code-wise, given the code, some of these concepts you are seeing here are in the open device since Helium. That's why I'm saying this is a building of existing work, and some of the features are already used by some of the applications. For example, binding applications uses this similar API where there is a data tree candidate, but these APIs are also type safe. So we don't need to cast if I'm listening to the node in the inventory, I don't need to cast and do the check. You get nice type safe API. You get a data tree candidate of node in the inventory.
So our data tree failed. So I would assume that's when you initially register. This is a case where you need feedback when you're doing a read.
Yeah, or for example, your node got disconnected from the cluster. You get the exception. This can be triggered when connection to external subtree source is broken. You disconnect it from the cluster. You cannot listen anymore. You got an exception. We propagate it to the user. Again, these APIs works for the single node, works for the cluster, but allows you to have better visibility what's happening under the hoods, without tailoring it to particular solution. Or imagine we have some different protocol for remoting some of the subtree. You get a callback, you cannot listen anymore because someone tore out the cable to the device. Device failed. So this also gives you a possibility to see that, okay, it is not possible anymore to listen because of some external event. And then you could do your processing, log an error, retry. So it gives you better visibility of what's happening. Then there is another interface, which is a data tree producer. this actually represents what your application is writing. Data tree producer, I'm showing the DOM data tree producer APIs. The binding giver could provide you much more helper functions. So this is a really core API. It's really simple. You have DOM data tree write transactions. You have a write transactions. You have an option to create a transaction, which can be isolated from the previous ones. This actually allows us to specify if we should batch and merge transactions under the hood, if the data store isn't catching up, or if the data store is remote, so we can compress your transactions into smaller ones. And when you specify isolated flag, the transaction will be transmitted to the data store and to the listeners as is. So, for example, where there is some significant state change occurred. You don't want to lose link flapping in the compression. Questions?
The API should be called new transaction, just to be consistent with the rest of our. What is it called? Create transaction on the consumer side. I think it's called that.
New read only, no, we are using a new terminology. New read only, new read write. But in the transaction APIs, we are using terminology new transaction, new. But at the other interfaces in the MDSL, we started using a create word. Yeah, we need to figure that out. So we are at some places I think the create is used at more places than a new. The only place where there is a new transaction is only the data broker API is using the word new. New should be constructor only. Yeah, so it allows you to isolate. Basically, do not merge this transaction with previous. This gives you control over the batching.
So it's not a chain. So you'd say isolated true if you want a chain.
No.
Isolated false. Whatever.
No. If you want ping pong, what we had a ping pong buffer which compressed the transaction based on the transmission speed. That's basically isolated false.
It's like reuse the transaction.
Compress the transaction.
More operations are.
So they're automatically chained.
No,
All the transactions in data tree producers are chained. So yeah, you are writing your transaction is based on the other. Actually, what we found from the most use cases is the new transaction APIs and normal data brokers, which allows you to have a transaction. Most of the application use that they wait for the transaction in order to start next transaction to see the previous results. This gives you that you don't need to wait for new transaction, which requires the previous to be completed. This doesn't require you to wait for the transaction to finish. So that's the chain part of it. That's the transaction chaining. Your transaction requires the previous to be finished and builds on top of it. That's the transaction chaining part of it.
So, yeah, no, I got you. So you could obviously chain together right transactions. So I mean, looking back at the current API, transaction chain, view write only, write only. But we always also had all these rewrites. I don't.
Yeah.
I don't know what the.
No. And actually, the other part, read-write semantics are now. If you construct your applications in such a way, you don't need to do. If you have a chain, in chain you usually don't need to read, because you were the one who wrote the data previously. So you know that state.
Yeah, I know, but when you look at the Java document,
Yeah.
one of the examples, this was done. So if you've written data, if you've written a whole bunch of data, then you do another read on it, so that you will see what you wrote. I mean, it seemed like that was a very important kind of workflow.
I will figure it out.
Maybe it isn't. Maybe nobody cares
Let
about
me
it.
see if I can get this right. I mean, when you do a create transaction, you get an instance of the transaction.
Yeah.
When you specify false, it's possible that when you do the next create transaction, you get the same instance.
No, you will get separate transaction because you still may want to cancel it. You will do the separate, but once you submit these transactions in the background as what's already also implemented and you are doing in the clustering also is you merge these two transactions into one. Because you have a transaction chain, it means that if the transaction A fails, the transaction B also needs to fail because it's based on the A. So it's really the same as having one huge transaction.
It's the same as having one huge transaction, but the instance that is returned is going to be a unique instance.
Yes.
It's just that underneath it's going to
Underneath, it could be one backend transaction. It may not be, it could be.
So front-end transactions are going to be different as far as the data store is concerned. There will be one transaction, just like ping pong.
Yeah, like ping pong. If you do the false, we cannot go to the ping pong behavior.
When you do collapse, so this is an ops guy and an operator. If you do collapse and they're different users, make sure you track what user put in what change.
So this is a per user. We are collapsing per, so this is API. Here is your application. So we are collapsing, and this data tree producer API represents one concrete user. So we are collapsing only his data.
Okay.
So maybe I was not clear. It represents producer context, which is one application, one instance of the application.
That's fine.
Shouldn't isolated be true to not collapse the state?
Yeah, setting isolated to true disable state compression for this transaction to not collapse the state.
Yeah, I think the
I
name of
thought
that
the
variable is a little
The
bit.
word shouldn't it be like, I mean, if you're isolating it, then you think of it as all your transactions are going in the order in which you created them, with the operations that you put on them.
Yeah.
So when it's true, that's the feeling I get, that's how it would work. When it's false is when you would want the state compression to happen.
Yeah.
I think that needs maybe a change of the variable name, because last time I looked at the code on that, I think.
So compress true and false.
Well, I think there was a discrepancy, like the variable name was called something and then the Java document.
Oh, yeah, we can fix that.
Anyway, we can fix all that.
And also, you may want to,
Variant, that was it, yeah.
and you may also spin off the subtree producers. So you may want to spin off, and that's pretty also common use pattern. You created a transaction chain which represents your top level context. You started writing, but then you want, for example, to write each switch separately. So you have the option to create a data tree producer which will base on your transaction chain for specified subtrees. And that could be used by different thread, different data change listener, different application. A different part of your application, and that chain is separate from the parent chain currently. But once you create a producer, these are auto-closable. The parent data tree producer cannot write to the subtree for which it created child's data change listener.
What's the scope of the per user journey? Is it a transaction? Is it
This is a transaction chain replacement. It's set of the transactions.
so it's local to a node, right?
It's what do you mean by local to the node?
Doesn't span nodes to the cluster.
No, it doesn't span a node in the cluster.
Okay, so there still can be conflict if I have two producers putting data in the same tree from different nodes in the cluster.
No.
Solve that.
That's the other part of the API contract, is which when you are creating the data tree producer, the top level one, because this requires you to have not conflict for the data tree producer. So there is no other writer using this API to particular subtree. And to get the original instance of that, you need to create a DOM data tree producer on the broker. And this one will throw you a conflict if there is someone else in the cluster using this API.
So that one is clustered, and that one guarantees that there is only one producer
Yeah.
in a cluster, right?
For subtree.
For a given subtree.
For a given subtree. And this API allows you to spin off
Only at any given time.
at any given time.
When the producer gets shut down or whatever, or the transaction completes, somebody else can write in that
Yeah.
subtree. Okay.
When the producer is closed down.
Yep. Understood.
And basically you could, and that's why this one doesn't throw the exception is because for given subtree you got already the lock. So you could spin off this sub-applications for the subtree.
Okay, so
didn't get there yet, but it will be easy.
Details, details.
It will be easy.
No, but, so what, from my understanding of this, correct, so if there was a part of the code that, say, created a producer for the config data store, for a part of the config data store, so basically, he's gonna be the exclusive writer for that little part of the data store, right?
Yes.
But can't there be cases where RESTConf, when you want users to be able to change a part of that little tree?
So, and that's also, this is,
From that, doing that?
so, and this is something like having a log for the subtree. And actually, if you imagine your application is talking to the other application using the config. You deploy the application in your controller, which uses the OVSDB, for example. You are writing to the OVSDB config. And now users come through the RESTConf and start playing with their OVSDB configuration the same time your application plays with it.
Yeah.
What will happen? Usually bad things happen.
Well, there may be parts of that whole configuration where, the code puts something in there, and then users are able to tweak it to the rest.
So if you put the initial configuration, create producer, drop the initial configuration, close the producer, you boot up the machine with that initial configuration, which is done. If the data tree producer is, so once the data producer is closed, that subtree is free to write for the other one.
Is what's gonna screw people because
So the data tree producer subtree is, I use this subtree over the time, and I do changes to it over the time.
yes, yeah, I can see somebody, initially, this is why I initially thought of this, is I create a producer, because it's like a transaction chain, it's a transaction chain.
Yeah.
I create a producer beginning of my module, and then I just use that for, over time. Create a new transaction, create a new over time, so I keep that producer around.
Yeah,
That's the way I would code it.
yeah. That's the way.
I don't have to create a new producer every single time I want to do it right.
No, you don't want to do that. You don't.
But then maybe I'm missing something. Then
So that create producer is for subtrees. When you want to spin off another instance, load balancing, workload for specific switch. So if you are a statistics manager, collecting the statistics.
the tree, right? It locks that data. This is why maybe I'm misunderstanding.
Yeah, that locks that data tree.
So
in these APIs.
So that whatever's under there, nobody else can write to it. It's
Yes.
RESTConf.
Yes.
I don't know. Maybe I'm wrong. Maybe that doesn't.
And actually, yeah. And once you destroy that producer, the subtree is unlocked.
Don't destroy the producer.
If you don't destroy the producer, the subtree is locked.
But that's my point. Is I think the way I understand or read it, maybe I'm.
So imagine these are the operational data you are writing. You are writing some statistics for the OpenFlow or for some device, and you don't want the other application to mess with your data.
I get
Do you
that.
want?
I totally get that.
And if you are writing an application inside the controller which configures the other application, you don't want the other users to mess with your configuration of the other application for you. Do you?
But what do you, I'm talking about config, so, because config can be changed by RESTConf. So,
Yes, and in RESTConf you could say the resource is locked. In RESTConf you could say that the resource is locked.
Why do you tell people to use the same way? On the one hand, for efficiency, you want chaining, right?
Yeah.
Because if I need to write something, then 5 minutes later I need to write something, but I don't know if 5 minutes elapsed, but I need to make sure that I can see what I previously wrote, right? And make sure, because it's usually how people, and we always, early on, we always say, use chaining, right? Right. So you gotta keep that chain open.
Yeah.
And usually that's how you do it. Keep the chain open.
That's the pattern of the tree.
That's the pattern.
Yeah, and actually the chain makes.
Right. Yeah, until it breaks, the chain, yeah. So that's, so now, based on, the semantics of chain, if you bring that forward, but basically, how do people use chains now? They usually, when they create modules created, they break the chain. They keep the chain open until it breaks, and then they gotta create a new chain until an error.
Yeah, and this chain, and given that,
You're gonna, it's okay for a user to maybe change a part of the configuration.
So in that case,
Am I the only one
yeah,
that thinks maybe that might be a problem? Or?
What will happen to the augmentations done for this tree? Would let's say I'm writing an application which does augmentation of I won't be able to write at all.
okay. Yeah, so there's feedback here, and I will try to incorporate it.
I'm just asking a question. Is that correct understanding?
Yeah, so actually one of the ideas behind that is usually applications assume a single writer. The other part is applications which locks the whole tree. You don't have really that application. You don't that application didn't specify its intent correctly. So I wouldn't trust that code. It locked the whole. It actually says I'm writing all the place in the controller. And maybe it's okay. It integrates a lot of things, but usually your application, your Java application, which is running, and is configuring the other application, don't want you to mess with its data, with its configuration. And Maywan, go ahead.
I'm just curious, like, is there a timeout or anything? Because people are going to screw this up, right? Always do. And you want some sort of safety net to make sure that when they screw up, you say, okay, buddy, you had this too long, flag them, log it.
So I didn't present here registration APIs, but the registration API actually gives an error to anyone who's tried to access something which register something which is already taken. So that application gets the information that these resources are already taken. Your application gets the resource.
So it's the bad guy who already has it and you want to flag it. If he holds it for 14 days, you at one point.
Okay, and that's a bit of a policy. How I define who's the bad guy in your deployment.
You have some upper bound that says, you know what, I don't think 14 days is reasonable to lock out the instruction.
And I think maybe 1 year is not reasonable.
Whatever.
Or 5 minutes. So that's much more like policing on the deployment side.
So Tony, if I use the producer API and I create a transaction and that locks a tree, can I use the old API and still post, like, put some data? Will that work? Or will it
Yeah, we need to figure that transition there. So I actually, currently we probably will not enforce the single writer during some transition period, but having a single writer for particular time to particular subtree of the data, and be it the configuration, be it operational, over the time it decreases the complexity of the applications, waiting for that retry and so on.
this API might be fine for operational data. I know that. It depends. Basically, augmentations is what I feel that have problems.
I think that's kind of pattern that Amin is bringing up.
So yeah, but for the augmentations, let me continue. For the augmentations, which means given the operational data, some application published that data. I am publishing my data, and someone is writing augmentations to my data. I should have a probably veto power of these augmentations, or I should be notified that these augmentations. Yeah, we need to figure out that pattern.
I have a version of a code, or I have a module that's writing the base data. I have written a different module and I don't want to touch the original code that writes the augmentation. That's a valid use case. How do we solve that?
Okay, need to figure it out.
Okay.
But we need also for the original model code to be aware that someone else wrote an augmentation to my data. We need also that pattern to introduce.
I would agree, but we also need the thing where you have a
Yeah.
piece of code that's writing data, you're writing a fix or you're writing an extension of that function, you're writing a new feature. You don't want to change
Or there was the other question or the other idea which went around that if we have a single writer, if we have a single writer, or you could take not exclusive, but you are a writer to particular subtree. You use the data tree producer. There was the other idea that all the other writes will be directed through you, so you can veto them to that subtree which you are holding the lock. Which is same what I said, that you see that augmentations coming. That application has visibility if someone is writing the augmentations there.
framework for that so that me as an application don't have to worry about creating
About creating what in the first place?
This framework where I can fund, where the augmentations can fund.
So that's maybe the requirement for the MD-SAL, that when we detect this situation, we will notify that application and we will provide probably APIs for that, that the application will get that information someone is trying to write. It's okay, it's not.
That's what I meant under the framework. So yes, that's
No. The idea wouldn't be that idea that this is that communication patterns should be provided by us, not by up specific level. Yeah, that makes sense.
if we're requesting that it's only one writer and the original app that has to write all the, even the augmentations that data store, then we need to provide something in the MD-SAL that supports that.
One question, real quick. When I do ops, when I'm doing upgrades or changes, having a back out feature that says, okay, things went really, really wrong, I need to restore the original config and back it out is one of the bulletproof, carrier grade tests we apply. Is there in this framework a way to do those changes, store the old tree, and then commit it to some point, and if something was very wrong, restore it to an older version, and then keep going?
So you are asking if it is doable using the APIs, or you ask for the use for that kind of the feature?
This is a framework question. Yeah, is that part of the framework, that thinking, that I may have to go to a point and say, these changes need to be backed out instead of stating the network, pull it out and go restore to this.
So currently we don't have the API for that, like that, but it is doable that you did the changes. So before your point where you are going to be unsafe, you read the config. Do your changes, it failed, you write back that old config. So we want easier APIs that create a snapshot, do that, roll back.
It would be nice if it's in the main philosophy of the database, of the trees, but, okay. I know there's a way to do it.
And you want to roll back the set of the transactions instead of one transaction.
Generally, this is with either upgrades or large topology or other changes where you execute, you flash cut to it, and if all hell breaks loose, you fail back. You pull the patch back out, you restore it to the last good config. And if that's really part of the core framework that you want, because it's so crucial, more so than something you put on the outside. Understand that.
I understand what
Yeah, that's
probably.
If we have vendors in the lab that don't do that, you don't go in the network, because I can't have a production network with millions of dollars of revenue going, do an upgrade to it, something goes wrong, and then all hell breaks loose, and I crash it, and then I have to rebuild from the ground up. I need to be able to restore to a point and keep going. So that's one of the tests we apply in the lab. I'm saying it because you need to think about it for the framework more so than what you guys are doing already.
What about backing up your persistence?
Sometimes if you make certain changes, and wipe out interfaces, that restore won't catch them. So this
And,
is
Actually, I will look into that a bit differently. That's what you described is the manual workflow currently. But you can imagine that workflow for the provisioning application when you practically want to provision something, do some changes, and that application is aware during the observation of the network that it needs to roll back.
yeah.
And given that, yeah, what you described, backing up the persistence works for deploying the manual deployments where there is a human involved. Going forward, this actually makes sense to have the application at the API level in a way that you could write the applications in such a way that they have their own, they can create their rollback strategy.
Correct.
If they broke something. If you observe and if you create an observation loop.
Just for clarity, when we get ready to do a major upgrade like this or a major change, we actually lock everybody out of the API. We take the snapshot and lock everybody out, because if you don't, it gets all the other subsystems out of
And that's actually the major upgrade to the configuration of the network.
It can be, or a module of the network, right? It could do a subsystem, like, you know, anytime you're doing an upgrade, that's how we do it, because if you're working in a live network, you know, now you can work with Tech, there's other ways of doing it, but when you get down to core elements, that there's only one tree, and on the root for everybody, you have to use a slightly different philosophy. Anyway, thank you.
Okay. And there's just some examples of the applications, because this producer API allows you to actually do the data change transformation, or be only the producer of the data or the consumer. So for the producer only, basically connected to the external system, RPCs, notifications, or external system, your application is writing data to the data tree. Really simple pattern. There are some examples. Reporting the status of the network to the operational. Adjacency rip in the BGP, netconf connection status, OpenFlow switch status, statistics. Then there are types of the components or the applications which are consumer only. You listen on the data tree and then push to the external system. For example, OpenFlow forwarding rules manager, which pushes the flows down to the switches, or using the RPCs down to the OpenFlow plugin, which pushes it to the switches, or in the BGP use case, there's adjacency rip out. And then there are the applications which are purely data-driven, listens on one subtree or set of the subtrees, and writes the other subtrees out. For example, group-based policy. They are getting several subtrees, for example, set of the endpoints and set of the policies, and then render the mapping of the policies to concrete examples of the renders. Usually these applications consumes multiple subtrees, or one or multiple subtrees, and their work is, they are mostly stateless if they don't need to read this data. If they can get all the data injected into them directly, they are moving to being stateless. Only state which is actually when they are constructing their initial configuration. For example, on which subtrees to listen. And that's, for example, group-based policy, topology processing framework is using that, or in the BGP application, we are using that. If you have the load effective rip in is listening on the adjacency rip in. So you have a component which listens on the adjacency rip in, does the policy selection, do the best route selection, does the effective rip in, and then then there is a load rip which is listening on multiple effective rip ins, does the policy, applies the policies, and writes out the effective rip in. And there are applications which are working purely on the data trees and data store, and what they are doing is just data transformation. And these new APIs were also designed with this from the feedback from these applications. There are some example workflows here. Basically, we have doing the render correctly. So these APIs, as I mentioned, gets you a state, or on the data change, it gets you a state of all the three subtrees you are listening to. Then application writes to the data tree producer, which is responsible actually to figure out which shards to write or where to put this data. Very simple workflow. And actually, this allows also for some faster lookups, because if the application states the places where you are writing before, we can cache which shards to connect, which shards are affected, so we have a better visibility into the topology of how the data are moving through the system. And we need only to update the sharding layout cache when the sharding layout is changed. So we can actually create more effective context for your application for writes. because currently the data brokers and everything, since we have transactions which can go span everywhere, we cannot cache or we cannot pre-cache the information specific for your application. So the lookup context is much more smaller. There are some example call diagrams. That's much more implementation specific. So, and that's also the important function, how this affects existing applications. This will go as a docs documentation to new APIs. I don't want to put anything into wiki. I want anything put into the repository and have a documentation rendered out of it. It's better than to maintain it at 2 places, but we will end of the Beryllium and we will start copying the things from the wiki.
I don't think read can be implemented in the short-lived data tree listener. If the write into the data tree happened before you created the short tree data tree listener, you will never get the data back.
The read-only transactions could be implemented that way.
How do you trigger the event of?
So the data tree listeners and data change listener have always the concept of initial data change event.
Okay.
So when you register, the pre-existing state is pushed into you, Jan. So basically, that's why the application doesn't need to do read if they are using data change listener APIs, because even if the state existed before the application started, they got that state injected.
Maybe very inefficient in some cases, but you're okay with that?
Same as read.
Yeah.
No, but the local read is fast.
So actually, this is the other way around. Currently, the initial data change event is implemented using the read. We will switch that relationship.
But when you register data, I mean currently, it has to create an actor. It's got to, the registration's got to get the current data. I mean, it creates an actor.
Yeah, and any pattern and actually ask in the AKA creates an actor.
Oh yeah, but a local read now does not do that.
And yeah, we can detect the.
Optimizations, it does not.
And that goes same. We can do the same optimizations for data change listener.
Yeah.
Under the hoods, we have a visibility into what is local, what is not, so we can do the same tricks.
Well, but not if you don't have an explicit read, because you don't know if they're reading, if they just want the one-off initial data, or if they want, or you have to pass a flag data.
Yeah, and maybe that would be that this is the one-off listener, or this listener will.
No, it was self-destruct after the first notification.
Actually, there are listeners such that also in the test. They are useful for the testing when you need to test that your application, unit tests, your application is writing correctly. The self-destructing listeners are good for the unit testing. Ed actually pointed it out on this.
It's not going to happen. People are going to use a read for some read. That's basically what they do.
Yeah.
You will do a listener and then get the state.
So you could still have something like read, but in the backgrounds in the system will be implemented like this.
Well, yeah.
That's there is a difference what's the front end and what's the core.
No, because see, both the APIs are usable. There is a read on one API. I'll just use that API to read. Why would I constrain myself using only the producer and consumer?
So it depends why you are doing your reads.
I want to do a read one time because when I start up, I want to know what is the current state of the system.
Okay.
So that I can, put my module in the right state.
And then when the state of the current system changed.
It's fine. Then I'm going to do a data change. I'm going to register for data change listers,
Okay.
right? Based on what I actually read. Sometimes I read all the nodes in inventory, and then I started I made myself a data change listener on each and every node.
Not only start up, like
So that's similar as registering as data change listener to the inventory, and then spinning off the concrete, more specific listeners on the subtrees you want to do. Because even if you register to these 5 nodes during the startup, the 6th node may pop up after the startup.
Yeah, but again, in that case, I wouldn't want to do like a short-lived registration.
No, but most of the time, applications are doing the reads periodically to observe current state of the system. That are the most common. One of reads are, if your application is doing some transformation in the network or is running in the controller, one of reads are not so common. One of reads are good for, I want to observe the state, I'm something external, I'm external entity, and I want to observe the state of the system. But inside the system, when the application is running, you usually do something periodically over the time, and you want to be notified when something changed instead of going and periodically pulling data. So reads are usually in the system are there is something external RESTCON, which is REST, which is not stateful. There is some stateless intent from the external system on which I need to respond.
Yeah, it's better from an ops perspective if you send, like if you use VMware. VMware does it really well. If you put a topology up there, and it will give you little change errors that tell you that, hey, something changed in what you're viewing, but it won't necessarily do a read and refresh unless you tell it to. And it's better to get that feedback up so you can look at what was changed and figure out, do I need to go read and refresh or not? That's a much more conservative way, I think, of doing it. And it sounds like that's what you've done, right?
Yeah, that was the idea, actually. And that's the difference. People which are used to the REST APIs. In the REST, reads make sense because that's how the HTTP operates. But once you are going, and this is still Java, I'm running inside the controller. I need to be high performance. I need to be, I'm doing usually when I'm running, I'm doing something which needs to react to the change of the network or the change of the data in the system. Most of the use cases are like this.
Yeah, well, there's definitely a lot of use cases like that, but I know there's other I've seen use cases where, maybe it's an RPC or something, they have
Yeah,
RPC.
and RPCs and this,
Read something to decide what to do, right? Maybe all the input you get in RPC doesn't tell you anything. You may need to go read somewhere else, get a snapshot of something else, and then decide what to do.
It depends what the change is, right? How severe or some changes, I don't care, who cares? That's
It's not, no, maybe I need to go read a password in the admin. Maybe I've stored, password or something. I need to go read it because I need to connect to an external. There are use cases. for that.
Something similar.
Unless you just cache all that information.
On a data change event, there could be a reaction that you are supposed to go and read another feed.
Yeah, you need to read some information somewhere
So that
else
I can take an action.
I can take an action.
so, and that's why we have a multi-subtree data change listener. So,
It's not a listener,
It's
maybe
not
it's
a
an
listener.
RPC.
for the RPCs, yeah, it makes sense. The RPC is one of action, yeah.
Yeah. So, I mean,
But for continuous actions, do not do reads. That's a recommendation.
listeners, yes.
So you have to cache your data. Otherwise, you have to cache it. Same data that is already there.
Yeah, you want to cache it. If you don't cache it, cache it on the outside of this, so it doesn't do a read, because it's just going to slow it down.
Yeah, so we will pre-cache it for you. So, and that's less state for the application developer to keep track of. Easier application. Oh, and that's all to it.
Are we going to run into problems with how much memory we consume because most apps start caching data?
We are in that problem already. These applications are already caching data and are doing that in an inefficient way sometimes.
They will be caching data which normally they will just read.
No, they will be not caching the data. So that, So idea here was actually, you don't cache data. We get it to you. You don't need to cache data. We are providing it to you all the time. We are invoking you.
Yeah, so when you have to cache the data.
Maybe, maybe not. But that's the guys who can clearly figure out that to be efficient for everyone. Instead of having open-coded 12 ways to cache the data, we will have one system-wide way to cache the data for the applications.
Okay, before we stop, can you go over the transformer API?
So there isn't a transformer API. The transformer is much more a concept, which is when you are listening to some subtrees and writing, and based just on that data which you are coming from these subtrees, you are writing the next subtree. That's the concept.
And there's going to be some help to transform the data?
Some help to transform data. What do you mean? How? I can give you an examples of this which I mentioned here. And maybe over the time, but currently not. In the GBP, they need to do their own computation, how data are transformed. They need to map the endpoints to the policy groups. Then they need to resolve basically the policy, how the policies are extending each other. They need to compute that. It's not easy to provide any utilities for that use case. Topology processing framework, they are doing an iterative map reduce. So new node is added, they compute, they look at several fields, check if there is another node existing with that field. If yet, they merge it, do iterative map reduce on how the data change. Also, in their case, they are not transforming data, they are just shuffling it to different, they are just changing the name of the node. In the topology, they are exporting and writing just pointers there. No common code there. The BGP, I mentioned the BGP lottery, or BGP, I just effectively rip in. They are not transferring data in a sense that they construct it and rewrite it. They are getting the data from the data change event, and they are writing the same node to the data store. But what they do actually is when they get a new data, a new route is coming. They need to see if this prefix is more specific to one, and based on that they select the best route and write only the best route to the data store. So they need to have their own selection algorithm there. So they are not transforming data in the sense that, yeah, the resulting data structure is different. They are filtering data out based on the policies. And they are using the same data structure. There were just 3 examples which doesn't share any commonality and are doing the transformation. Oh, that one, that's ancient and that should be deleted.
Let's see, I think we have looked at a usage example.
Yeah, because usage examples are harder applications which already exist.
All right. Sorry, I didn't get your question.
I was talking about the same thing. That let's say we were talking about read not being necessary for applications. Usually, is what we were saying.
For Java applications, yes.
So, what do we do in this case when you're basically building some async system, right? Let's say in case of OVSDB and drop, you are getting an outbound API saying that you provision this, you're trying to, and OVSDB is giving you events of ports being added, and you're trying to
Correlate that. So you are listening to the OVSDB southbound. You are listening to the Neutron northbound. Each time.
both are async, right? So there is no synchronization. So what happens is, just to complete the thing, when OVSDB comes in, I need to see whether the related data is
Yeah, and new data tree.
If Neutron doesn't have it, then there is no action.
Yes.
But when Neutron comes in, I have to read and go whether OESDB has it. And then
And data change listener API, listening to the multiple subtrees, gives you a snapshot. Oh, OVSDB came in. Here is OVSDB data, and here is the Neutron data. You look into them. Oh, there is no Neutron data. I do nothing. Oh, someone configures something over the Neutron. You got, okay, this is the current data from the OVSDB, and this is the current data from the Neutron. I can do my action.
So you don't just register the event you are interested in, but the events as well as any part of the data.
So you're saying
you will need to process it.
it will give both subtrees.
Yeah, so actually, and that's the power of the SAP. That's the power for not only for us, but also how to understand the application is that using these APIs, application specifies their prerequisites, their prerequisite data in order to work. So it's a bit better documented, and you cannot and easier to debug, because if you look at if the applications start using this data, you could look at one place. Oh, these are all data this application needs, instead of going through all the code and figuring out, okay, this application is doing this listener, and oh, here it is doing the read somewhere of the hook, there is the other read of the hook. So it also will improve the readability. Were you working with the ACA?
Yeah, but RESTCON doesn't. You said
No.
talking about UI.
Yeah, so the reads are always implementable using these APIs.
Okay.
Because really what happens, the read is, because given that data change listeners or data tree listeners supports initial change event. That means when you register the data tree listener, you get an initial event.
That's fine. But
So read is just basically registering data tree listener, getting the event, and closing it.
so RESTCON will be listening to those events, but that's not the case, right? I mean, say I'm a user who logs.
So if you are external user, we promised you to provide a RESTConf contract. RESTConf contract needs to be implemented such way that if you do get, you will get all the data. That doesn't deal, the RESTConf doesn't even affect what MDSAL API is us. That's different contract. RESTConf has a different terminology than MDSAL. They are a bit aligned, but they are still a bit different.
But as you mentioned, that read will be.
Java API read will be discouraged, not RESTConf read. That's the different API. We are talking about MDSAL here, not RESTConf.
Agree, but I'm saying with RESTCON, will the read be expensive once you introduce this API or once you introduce this change?
So it will be same expensive as it is currently. So initial data change event is always a read currently internally. So it will be, the cost of that is similar, maybe a bit large, will be a bit larger. It depends how we will execute that.
So imagine, like, someone asked from the RESTCON that give me all the nodes in topology. I want to visualize that. So, say imagine you have 50 nodes in a
Yeah.
network, 50 switches. So, what would you imagine, like, with the changes that you're proposing?
So if if that is in one chart, we have a read from the
as a model strategy.
Because there's no way of dynamically adding a shard. If somebody wants to say, but
Yeah.
But it still will remain configuration based at least for cluster because this can be used by some other data.
And actually,
that API repeats for TSDR.
actually, these APIs gives you a possibility to create dynamic shards, to create APIs for dynamic shard creation. So it doesn't preclude you from having just config based. It just opens a new possibility for dynamically spinning shards, for having shards which are only local to the controller, remote shards, and then maybe probably to spin up new shards.
That API doesn't say anything about bullets. I forgot exactly what it was. It's a registered data tree shard or something like that, right?
Yeah, and that.
But the data tree shard that you register, is expected to implement some other interface. It doesn't say anything. All it has on it is get
Yeah.
So, and there's got to be more glue that says if you want to dynamically spin up a new cluster data store shard,
So,
there's got to be more alignment.
yeah, this API is capability based. So you register a data tree shard, and usually your shard will have you will implement the data store SPI. That you have a read write transaction.
Implement the data store in there. What they really want to do is say here, cluster data store, here is another.
And these are the user-facing API. Yeah, and they are user-facing API. These APIs are to make that possible.
No, this SPI is for anybody implementing a data store. So cluster
Yeah, what I'm saying is it doesn't seem like this API is suitable for dynamically spinning up a new shard replica or a new shard.
No, that's not suitable for that yet.
Right.
That's what we started. We started with really core, and then based on your ideas, we could introduce that SPI, and probably you will design it better than me. I can design this really low level tailored to how MDSAL works, and for the user facing, I believe you two will be better for clustered user facing SPIs.
Yeah. Okay. That's cool.
The data change listeners could read also from the followers. We will not go to the master. If all the nodes in the are present in the one chart, it's similar overhead as doing a read currently. If these are into multiple shards, it will be costlier. But that's already, as of now, the read from multiple shards is costly. The cost for that will not change.
But right now we put most of the stuff only in one shard, if you consider about all the.
So sharding affects performance. Going to the micro sharding and you have the data spread across 10 or 12 nodes in the future, and someone wants to see all the nodes, and you actually did the sharding based that you have nodes in different shards, and you have 12 of them, yeah, you need to aggregate data from 12 of the shards to provide the RESTconf query. Yeah. Is the RESTconf our primary API or not? And that's the question. If we ask, and that's actually determines how we design the solution. If we go way that we are designing the Java APIs, and most of the applications in the controller will probably be written for the performance, the cost for the RESTconf will be standard. Then we can go with having a RESTconf a bit slower for the reads of the whole inventory, but providing better and faster APIs to Java developers who wants to write these high performance applications. There is always a trade-off.
I don't see how you can discourage reading from data store. That's the most basic operation.
So, and that's why, actually, the idea behind this data tree was that the applications like GBP, if you did, and that's there is a difference with what type of the application you are writing. What we saw, and current APIs, which we have, works for the offset 1 applications, which are mostly protocol plugins. But once you go to the offset 2, when you are starting to integrating multiple subtrees, multiple types of So the other part which Moiz asked is we had also, along with the sharding SPI, there were proposed a set of new data tree APIs. This is a set of new APIs. Why it renders always like that? These APIs introduce basically new things which are subtree bound transactions. So you specify to which subtree you are writing beforehand, before you start actually doing any work. The transaction chaining is a natural part of the API. It's easier to use. It's called data tree producer. And actually difference between, and actually it is a signal to the MDSAL or to the underlying implementation. I will be doing a lot of writes to that particular data, to that particular subtree. And also given that this actually proposes also the better threading model for the applications which are using the data change listeners. So before we said do not do heavy work inside the MD-South thread. If you will be using opting into data tree APIs, you will be safe to use data tree change listeners and to write back to the data store during the data change listener callbacks. And also it allows us later to introduce maybe on per shard basis or configuration basis enforcement of the single writer. So there is an exception which could be, there are exceptions and contract which could notify the application that this subtree could be maintained by someone else. So it allows actually application to specify that I don't want someone else to stomp over and rewrite my operational data, for example. As I mentioned that before we discussed instance identifier based microsharding. It's basically mapping of the instance identifier to shards, and allows us to introduce later on dynamic and programmatic shard creation.
Okay with sharding API.
Yeah.
Let's delve into that data tree API, because that actually affects end users, right?
Yeah. As it is still, it's opt-in. If we introduce it in Beryllium, it's opt-in. Yeah. But I will push to migrate as much.
Is it such that we have to use one API or the other, or can we use both?
As an application, I would prefer that the application will use one type of the API or the other. Then there are the applications actually. So one style of the API or the other. Actually, there are applications which are using, for example, binding and DOM at the same time, and it makes sense in their use cases also. But they are not using that different concepts or different levels of the APIs. Current APIs are Helium level. They are Helium style APIs. They were introduced in the Helium. In the Lithium, we did not introduce any new APIs. And we are proposing a new APIs for the Beryllium based on what we learned by some other large-scale applications we created in the Open Daylight, and by the request from the projects like GBP and the others. What actually was painful for them using the Helium-style APIs.
Are we going to replicate anything from the Helium style APIs? Because is read going to be a different thing? Is read like transaction?
I need first to convince you and community, and then we can discuss deprecation. I cannot enforce that.
Okay, so I mean, let's say we assume nothing will be deprecated from that API.
But we will be discouraged.
Discouraged, but not deprecated. Which means they will use it for one more cycle. Right? It's not going to be deprecated.
You mean the current API or?
So we need to figure out that, but I am not pushing for deprecation. I'm So these new APIs doesn't have a read. RESTconf could be implemented using these new APIs. Really simple thing,